Okay, cool. Hello again. So, you know these chatbots that you all love? Well, Filip will talk about that. Maybe you don't love them. I see that ratings are going up or some down. So yeah, I mean, people are pretty biased to rating good or bad and nothing in between. So this is probably the outcome of that. This is again most rated talk. So we have a bias of the amount of votes some talk received. So please do vote. And of course, we'll have a public wall of fame afterwards. So for speakers, it will be very important to know how many votes he got and how he's positioning. As well, during the talk, it's easy to ask a bot. Just shoot question. He will say, okay, which talk to ask question, you ask a question, and I will know about it. The speaker will get a question, and we'll have a wonderful time. So I will let the stage now to Filip and enjoy his talk.
All right. Ovo je mutovano. Okay. All right. Hello, everyone. Thank you all for coming to this talk. My name is Filip Danić, and some of you might remember me from last year. I did a talk about React and Redux and front-end technologies in general. So this is kind of a change for me, doing something different, and I'll hope you'll enjoy it and have as much fun as I am exploring a different topic. Before we jump into the topic at hand, which is basically chatbots, what they are and how we're supposed to design and build them, I'd like to say a few words about me and give you some context behind what inspired this talk. So to reiterate, I'm Filip. I'm a software engineer. I work at a company called Spice Factory. We're a digital product agency that's 10 people strong, and we are looking to grow. And we work with both enterprise clients and some really cool startups. And we do a lot of experimenting and prototyping in our spare time. And as you might imagine, with only 10 people, we're always really busy and always eager to sort of stay on the cutting edge. And one of the experiments that we had last year was getting in on the hype train as it was leaving about chatbots. And we sort of tried it out, and some really interesting products came out of that, namely Sava. This is our conference chatbot and event management platform. It came out of this prototyping stage, and now it's a full product. And this talk is sort of a culmination of some of the lessons that we learned along the way that's meant to sort of basically help you get started if you're interested in learning about chatbots and making your own. So what this talk is about, basically we're looking to answer 4 questions. What chatbots are, where they are right now, why you should care and why they are interesting technical challenges, and how we might go about building them and how we might solve those challenges and what you can expect to encounter along the way. So let's start with a basic definition. What is a chatbot? A chatbot is basically a program that communicates via text or audio. It basically takes user input, it parses it, it analyzes it, it uses some sort of contextual state to produce a final output. When we're talking about text, you can think about applications in SMS, but also, the internet, Messenger, Viber, Telegram. When talking about audio, Skype bots might be an interesting thing, but even more interesting are perhaps these devices like Google Home and Amazon Alexa, which let you create your own voice assistants and apps, basically. So chatbots are typically used in dialogue systems that look like this. And this is an example taken straight out of Messenger, Facebook Messenger. And we have some different use cases here, such as customer support, e-commerce, and that's an early iteration of Sava at Devox Belgium, where he was a chatbot assistant similar to how he is here today. And so these are all cool, you know, all these images and buttons, but those are really enhancements to what makes the core of a chatbot. And that should be a conversational interface. You should always be designing around communication. So when you strip it all down, it should look like this. It should be a simple exchange of text. This is a bare bones look at a real conversational interface. You should be able to build a chatbot that can communicate like this. I don't know how well you can see the image back there, but it's basically just a simple chatbot that lets you order pizza in the same way that you will order it via phone. So how does this communication happen in a technical sense? Well, it's usually facilitated via secure webhooks. These are provided by the third-party vendors you're working with. For example, here we're using Messenger and Telegram. These provide you with a secure webhook, and it's basically just HTTP, which you should already be very familiar with. And JSON is like the lingua franca here. It's basically the format used to exchange these messages. Each platform has its own unique format and structure, and you're expected to build your own parsers that can interpret these into pure text and take your output basically and adjust it to what the platform is expecting. So before we can get really into like the technical crux and everything, I just want to address the idea of why this is happening now. Why are chatbots a thing? Why is there certain hype around them? They're kind of a buzzword maybe. There's one good reason that's not hype and not marketing, and it's this graph behind me. So at some point in 2015, these messaging applications such as WhatsApp, Messenger, Viber, they actually overtook social media networks in terms of active daily users. And it's not just how it's not just about their growth, the fact that they have more users. It's about how engaged these users are. So the home screen and the lock screen are saturated with messaging apps. Not only do you probably have a lot of them, but you're also probably constantly being bombarded by push notifications, and they're invading both our personal space and, you know, on business, in terms of business, because we use apps like Slack, for example. So in a way, chatbots are what we need in order to engage customers and users on these platforms right now. And you might be tempted to think of chatbots as sort of like these new micro applications that are built on top of these messaging platforms, which are not just like some sort of OS, but like an app store in itself. So what are these, you know, top platforms I'm talking about? Who are like the big players here? Well, I think you'll probably recognize a lot of these logos on the slide. In fact, I think we might do a really good test here. Can you raise your hands if you have 3 or more of these applications installed? Okay, basically everyone. Let's up that up. Do you have 4 or more? Okay, still the entire room. 5 or more. Okay, some hands are going down, but most of you are still saying that you do. That's awesome, and I can sympathize with everyone. It can be pretty chaotic because some of these you're using to keep up with family, some of these you're using to keep up with this group of friends, with that group of friends, with colleagues, with business partners. It's crazy. It reminds me of this comic from XKCD. It's a really good look at how fragmented all of this is, and how we're using everything and we have our own preferred platforms. But if you look at all of them, they're sort of evolving in the same way. You can't argue that there is too much of a difference between them, and You'll find bots on Slack, you'll find them on Messenger. Everything is sort of going in this one direction. And all of these platforms are encouraging developers to come to their platform and build bots. And big brands are already sort of jumping in. Messenger is extremely aggressive in this. They're working a lot on their APIs. They publish a new version with new features like every 4 months or so. Now they're integrating natural language processing within the platform itself. It's really interesting. And they're kind of leading here in terms of developer experience maybe. But like I said, the core experience will always be the same. When you've built a chatbot one way and you've done it right, it's very easy to sort of migrate it and adapt it to a new platform. And you know, this is basically where we transition into the more technical part, which is how we're going to be designing and building these chatbots. And by the end of the session, you should have a pretty good idea of how to do this and hopefully build your own. So let's get some technical stuff out of the way there and talk about categorizing chatbots. This will help us sort of set our expectations accordingly to the work that we're about to do. So first way of categorizing chatbots is by their model, how they're basically generating these responses. Retrieval-based chatbots, which are basically almost all of chatbots right now, work by interpreting your messages, analyzing them, and finding a response in some sort of database that you can use. Of course, these responses can be dynamic, they can incorporate context or something, but we're talking about a limited set of possible answers. Generative models, on the other hand, they work a little differently. They're much more sophisticated. In theory, they can provide you with an unlimited amount of answers because they're generating them on the fly. The quality of these answers will obviously vary based on how good they've been trained. And this is sort of where we're dreaming of heading today. Big tech giants are obviously exploring this. There's a lot of research done on it, but nobody's really an expert in chatbots yet, and nobody has really solved this and built an amazing example of it. The second category, basically, where we can put chatbots is based on their domain. So what set of responsibilities do they have, and what are the domains where they're operating in? In terms of a closed domain, we're talking about a specific niche that the chatbot is working with. So for example, we're working on a white label solution for financial institutions called Cognito. It's like, he's meant to basically help you control your finances, manage your payments, see offers from your bank, and so. And this is your closed domain, handyman kind of chatbot. The open domain is this idea that a chatbot can be able to communicate with you about just about anything. And if you put it on a little line graph with these two dimensions, you get something that looks like this. Most chatbots are in this green square right here. They're operating in a closed domain, in a specific niche. They're using retrieval models. So the amount of things that they know and can do is very limited. We're working towards this yellow box here, this idea that we can operate within a niche, but know so much more about it and generate new answers for the users. This is very convenient and important for things such as technical support. This idea of solving the user's problem on the fly and not being completely dependent on a set of answered questions that were answered previously. And the purple box over there is like the holy grail. I mentioned some tech giants earlier. This is where they're basically trying to be with stuff like Siri and Cortana, Alexa. This idea of having a personalized chatbot assistant. And in the coming years, this is where most of the industry will sort of be gravitating to. This idea of building chatbots that operate in a closed domain, mostly based on retrieval models, but where applicable, extending their functionality using generative models. So when there is not a case that can be solved using a database of answers, generate those answers on the fly. Okay, so that's some terminology, some idea of scope. Let's try and get into the technical idea. And, you know, it's basically, well, how do we build one? How do we make one? And I'd like to give you a little demo here. This is a small chatbot that I made in the speakers lounge today. He's meant to be very cute and entertaining. Do you remember like Tamagotchi and virtual pets? It's sort of like that. He's like your personal AI for managing your kittens. So I'm going to greet him right now. And, you know, he's responding, hey, what do you want to do today? And I'm going to say something like, you know, how are my pets doing, you know? What I'm getting here is a response which basically says that my cat Jake feels good and lazy, and oh, Jane feels sad and lonely. Well, let's try and fix that. Maybe I could try playing with Jane. Okay, and the bot is asking, great, what would you like to say while doing this? Well, let's say, Jane, you are adorable and cute. That's so nice. Jane feels a lot better now. Okay? And why am I using cats? Well, if you're a millennial like me and you don't reference memes and cats in your presentation, then why are you even giving a presentation, right? So I'm gonna play with John, maybe? Oh, no, my cat isn't called John, it's called Jake, okay? I'm gonna play with Jake then. But he was a really bad kitten, I say. So I'm gonna say, Jake, you are so lazy and horrible. Oh, that's so mean. Jake does not feel nice after that. Well, Jake shouldn't feel nice after that because I just scolded him in front of a live audience and a live stream. So I think that makes sense. And you know, this is really cute and entertaining and whatever. But there's actually some really interesting stuff going on behind the scenes here. Namely, natural language processing that's basically parsing all of these messages as they come in and deciding on what the next response should be, as well as some form of sentiment analysis. You saw that when I was nice to Jane, she reacted very well to that. When I was mean to Jake, he did not feel very good about it. So let's segue into that and basically talk about those things today. Natural language processing and sentiment analysis. So the question is it easy? Spoiler alert, it's probably not, but you don't have to worry too much about it. Because today, most machine learning systems and services end up looking something like this. So if you can't see it in the back, there's basically like two people talking. One is standing on a pile of algebra and vectors, and he's saying that if the answers don't end up being right, you just turn the pile a bit until they do. So basically this idea of tweaking your parameters until the customer is happy with the results. It would be good to move away from that, but this field is so heuristic driven and not always generating exactly correct answers. So let's talk about the first major building block of creating a chatbot, natural language processing. NLP is, of course, a very hot field in computer science these days, and it encompasses a lot of various problems. Our main focus here will be the application of NLP to understanding human language, both in terms of syntax and perhaps more importantly in terms of semantics. There are a lot of terrific libraries, a lot of terrific third-party platforms that can do a lot of this for you. It's up to you to decide on the pros and cons of what you're going to use, but it's still very important that these libraries support some very core features and that you have a good grasp and understanding of what those features are and how you're supposed to use them. So let's look at an example of some natural language processing that you would typically employ when building a chatbot. So let's start with a sentence that looks like this. My name is Jane and I am a software engineer. Okay? There's a conjunction there in between that basically splits this into two connected sentences. So maybe we could visualize it better doing something like this. Now, the first part that our NLP program is going to do is tokenization, which is basically dividing this sentence into tokens. In English, that's very easy because tokens are usually separated by white space and punctuation marks. In Chinese, for example, it's not really that simple. The next thing we would do then, once we have these tokens, is analyze them in terms of syntax. This is also a lot easier in English than in many other languages. And what these words below each of the tokens are is point of speech tags. And you've probably learned this in school. You know, this is a noun, this is a pronoun, this is a verb. This is basically what we're doing here in this step. The next thing you also learned in school is word morphology. And it can also be very useful in terms of syntax analysis. So, is the given token in singular or plural form? Very important when dealing with objects. Is the user buying one or multiple products? If multiple products, how many products? Also, in terms of verbs, is this verb in present, past, or future tense? This can change the meaning and the context of the sentence completely. Another thing when talking about own nouns, in Serbian vlastite imenice, in case you're not sure what that means, is to have basically a good natural language processor that can help you as soon as possible to identify first names and possibly people and organizations. This is very important for later when we are trying to extract entities within our sentences. So this is as far as we're going to go in terms of tokenization and syntax analysis. The next thing we want to do with this bag of words that we just have is define relationships between these tokens. So how would we do that? Well, we have a very cool tool for that. It's called a dependency grammar. And once we break down a sentence, it might look, something like this. This is a nice way of printing it out. But all of these dependencies aren't necessarily the same as with a typical graph, each of them having a certain attribute assigned to them, these lemmas and tags that are present. This is a more academic notation of this graph, basically. And the whole purpose of doing this is so that we can define the root of our sentence, so we can define the subjects of our sentences, and basically analyze if a sentence is made out of multiple terms, multiple sentences, like R is here, with us having one path which is defining the name of the person in question, the subject in this case, and their job role. Okay, so I mentioned something about entities, and so far we've been talking about syntax. This is a good segue into the idea of semantics. Syntax helps us define all these tokens and what they are, but it doesn't help us truly understand the meaning of a sentence. We can only do that once we incorporate this idea of entities. So let's take this sentence, for example. I want to book your conference call for next Tuesday. We could do the same kind of analysis we did earlier. I'm not going to bother you with that. Obviously, that would be the first step. But after that, we have to essentially use a trained text classifier to extract certain entities. And this sentence has 3 entities that are truly worth looking at. So this verb, book, to book, in the context of this sentence, it is a domain entity. It represents a specific action. It means that somebody wants to basically book something, or in this case, you know, buy. It's an important domain-specific verb here. Conference call is another domain entity in this case. What is the person booking? And finally, next Tuesday is like this idea of a generic entity. It's a time object. Why this is important to differentiate between domain entities and generic entities is because for domain entities, you will have to build models, train those models to identify what you want. But in terms of generic entities, such as time and location, you can rely on fabulous, pre-trained models to do this for you. Obviously, this will depend on the platforms you're using and what is available to you. But for time and location, you can rest easy that somebody has already done the work, right? So when we have this and our dependency grammar from earlier, we can construct a structure that basically defines this. The subject wants to book something next Tuesday, right? This is the final output that we care about after everything has been done. And we have our clear entities defined. We've stripped down everything else. And we have clear dependencies between those entities and the subject. And this is something we might be inclined to call an intent. The user has issued an intent to book something, we would say. And then we could basically give our chatbot processor this information, and he would run it by the user context and some data store and say, oh, well, this conference call is not available next Tuesday, or sure, you can book this conference, right? And this is a lot of work, or at least I think it's a lot of work. And you're probably not going to be doing all of this work by yourself, especially if you're a one-man team looking to experiment, build something really cool. So there are some really good platforms you can try. Open source over there with a commercial license for enterprise. With AI, recently acquired by Facebook, is going to be integrated into Messenger as well. Google Cloud Platform, another very powerful choice, along with IBM Watson. I'm just going to put these out there. I'm not going to evangelize any of them. If you want some context about them, hit me up after the talk. So that was natural language processing. Let's talk about the second piece of the puzzle, the second block, which is, I think, more interesting because it's not really done properly yet. And that's this idea of sentiment analysis. We want to understand what emotions the user is expressing and use that to provide basically a better response or tone to them. So it turns out it's actually very hard. So I'm going to start by presenting a simple algorithm to you. And then we'll see what the pitfalls of sentiment analysis are on that example. So imagine how we would implement sentiment analysis. let's take this idea of our NLP processor to tokenize some words in the user's input. So we have some sentence, we take every word out of that as a token, and then we run it through a database of words which are weighted by their sentiment. So each word having a positive or negative score. Then we could build something like a random forest classifier to assign probabilities to each word being used in a negative or positive context, essentially ending up with some positive or negative numerical score once we run that through. And here's what an output of such an algorithm would look like. So Johnny's has some amazing burgers. They sure do. And the algorithm is saying that this has a score of +4. This is on a scale between -5 and 5. Okay, so far pretty good. The naive algorithm is doing good work. So here's another example. On the other opposite end of the spectrum, Johnny's burgers taste horrible. And this is coming with a score of -3. Okay, so the naive algorithm is still holding on. Here's a third example. Johnny's burgers are great, but the staff is rude. So is this a positive or a negative sentence? Well, it's really hard to define, is it? This algorithm is leaning towards it being kind of positive, mostly neutral, assigning it a score of 1. Basically saying that great in this context is more important than the word rude. And we could go on with this. It might work, but it fails really quickly. So here's an example where it fails. This is bad, this is not bad. Each having a score of -3. So what happened here? Well, here's a the not here is a negation. It's not saying that this should be positive, it's just neutralizing the value. So the value here should have been around 0 perhaps. And you might be inclined to say, well, okay, just tweak the algorithm so that it can handle negation like this. And you could probably do that. But language is so complex and full of nuances that would have you tweaking the algorithm every other day. So going with simple classifiers isn't really going to cut it. So what would be less naive? Well, there's a lot of research in deep learning and neural networks that has produced some really interesting results. And it might be just easier to use a third-party platform like IBM's Alchemy, part of the Watson project. And here's how that service would have interpreted these two inputs. So this is bad would have had a negative score. And notice that Alchemy is also including emotions and their probabilities. The emotions here don't seem very accurate, but at least the negative score is good. So this is not bad. Well, it's saying positive, but with a very low probability, which means it's mostly neutral. And the probability of each emotion is very low, which further indicates that Alchemy is understanding this correctly as a very neutral sentence. But here's something that's not very positive. I enjoyed the show the same way I would have enjoyed petting a vicious bear. So this is an example of sarcasm, and it's a very clear example of sarcasm. So is today's sentiment analysis going to predict that this is probably negative? Not exactly. It's a positive with an 84% of probability and around 80% probability that the user is expressing joy. That's not very good, and there's a very clear reason why this approach to sentiment analysis is never going to really solve our problems. Because this is a sort of objective way of defining emotions. It doesn't take into account context. It leaves it basically up to you to analyze the user's previous behaviors. It's also very really objective. It's trying to say that every single person that said this would have meant the same thing with the same amount of emotion. So let me give you an example of that. Say that it's raining. It's a horrible day outside and it's raining. And you asked me, how are you feeling? And I said, well, I'm feeling fine. What that would mean is that I'm kind of annoyed, but mostly neutral about it. If you ask somebody else, my girlfriend, for example, and she said that she's feeling fine, that would have actually meant this day is horrible and I feel horrible as a result. So it's very relative. And this is why we haven't really cracked the case in terms of sentiment analysis. And I think it bears repeating to say that, because if you're going to be relying too much on sentiment analysis for your project, you'll have to have this in mind. And as I close this talk, basically, I'm going to give you some maybe final words of advice as you venture on into your future projects of developing chatbots. And this is the idea that you should teach your bot to fail gracefully. Here's a horrible example. Remember that pizza bot from earlier? It wasn't really that smart in the beginning. So, would you like a Pepsi with that? Heck nah, brah. I'm sorry, I don't understand that. And it keeps repeating that over and over and over because it's expecting a simple yes or no answer. As a designer of this conversational flow, you should have made it very clear what kind of answer you were expecting. You should also really be keeping context in mind. If the bot is failing 50 times over and over, they should maybe try a different approach. In fact, maybe they should go to the last message that was successful and repeat that message instead, this time with maybe some more context into the response you're expecting. Because if you end up building something that works like this, you might as well have made this, because this has some probability of giving you an actual answer that might help you. So, real quick, some challenges moving forward, because most of the people in the crowd here are, local like me from Serbia. Localization, really big deal. Serbian is not a very large language. It doesn't have that many speakers, for example. And it's not the only language that fits into this category. If you were to set out on building a chatbot in Serbian today, you would have a lot of problems because there are not enough high-quality natural language processing services or libraries out there. The second challenge, maybe not that intuitive to engineers, but the user will notice it. It's this idea of personality and writing. So remember when we talked about retrieval-based models, we have this fixed number of possible answers. And what you could do is have someone who's good at writing, someone who's a copyright expert, go through all of these and make sure that they have a consistent personality. If you're building a personality, if you're building something that shouldn't have any personality, that's okay too. You should be enforcing it. Think of it as a style guide of some sorts. Personality is something of your brand design, your CSS and your assets in terms of web design, right? But it's going to get really challenging as we build these generative models. So remember how we're saying that at some point we're going to be building chatbots that generate answers from scratch. Well, how are we going to know that these answers are all within the same personality, basically? We would have to enforce specific style guides through the grammar itself. So that's some really good food for thought, I think, as we close this talk. Once again, my name is Filip. Thank you all for coming. Thank you for listening to this talk. I would really like to give a quick shout out to my company, Spice Factory. We have a booth over near Orange Tassie, right basically near the first entrance. We have some hot sauces that you can try if you're feeling brave enough. And we also have a giveaway contest where you can win a Super Nintendo Mini. So thank you all for coming. And maybe if you have any questions, I can take them right now.
There's a question. But yeah, first applause. So, the question goes, do you perform automated testing with a platform, with a chatbot? And the question is if that is possible. And I will follow up afterwards.
What kind of testing? I didn't hear.
Automated testing.
Automated testing, yes. This is definitely a field where automated testing is important and relatively easy to implement. You have these, you're basically going to be building test cases that consist of test data. At some point when you have a lot of data of your own, you would just label it and use that to basically feed it to some module of your bot and check if the provided response was what you were expecting in terms of intent and analysis, not necessarily in terms of what the final text looked like.
Okay, and the other question is, what's your experience of developing for two platforms?
On development on?
Two platforms, on more than one.
Developing for two platforms, so in this case, it's Messenger and Telegram. So platforms, at the end of the day, we realized after much debate, should not matter. So your natural language processor is a thing in itself. It's like an independent module. It should be outputting results based on the text data that it receives. You should be building your custom code in terms of connectors with each platform and parsing that down to some sort of meta structure that you're giving to your NLP module. And then when it returns the result in this same structure, you're just parsing that for the platform that you were communicating with.
Okay, now live questions.
Hi. Quick question. How are you planning to address the problem with the localization?
So how are we planning to address the problem with localization? Honestly, I'm not really sure. It's an open question. Google is adding more and more languages in their natural language processing service, which is really good because in a few years I expect that they will really do a good job covering like the top 10 languages maybe. But for smaller languages, Serbian in this case, one approach would be to take an existing open source library and basically see if you can implement it on your own language. And I know some people who have done research in this area, building like some sort of contextual phrases analysis. So basically, we have this saying in Serbian, which is completely different from this saying in English in terms of syntax, but their meanings are the same. So I would definitely be looking, what research has been already done. So I hope that at least, answers part of the question. It's obviously not a real complete answer.
Okay, so yeah, that concludes it. So
okay.
Thank you, Filip.
Thank you all coming.
So rating.